Today, we begin our detailed exploration of Obidi's theory of entropicity, a formal framework that offers a rigorous, well-structured perspective on the fundamental origin of physical reality. This theory stands out for its logical precision and its ability to present an integrated and elegant account that challenges conventional views, aiming to redefine our understanding of how the fabric of existence emerges from underlying entropic principles. Throughout this presentation, we will carefully examine the core concepts and mathematical underpinnings that support this proposal, shedding light on its implications for physics and philosophy. At the very beginning, there were no physical dimensions or measurable quantities, no space, no time, and no matter in existence. This initial state lacked any structure or form and was characterized solely by entropy, representing complete disorder. It is essential to understand that from this fundamental condition, which was devoid of geometry or defined properties, all the components of our universe eventually emerged. This concept sets the foundation for exploring how complex systems and structures developed from an initially unstructured and entropic starting point. The entropic field, denoted as Sx, is considered the fundamental layer underlying the entire universe. According to Obidi, this field forms the primitive foundation from which all physical reality emerges. Each point within this entropic manifold carries intrinsic informational content, but this is not merely a theoretical or mathematical abstraction, it represents a genuine physical property. Essentially, the entropic field embodies the very fabric of existence, embedding information directly within its structure, which influences the behavior and characteristics of the universe at the most basic level. The accompanying diagram illustrates how the field is composed of interconnected points, highlighting Sx as the central element connecting this informational network, reinforcing its role as the core physical substrate. Entropy provides a way to measure the informational content in a system, which directly influences how distinguishable two nearby states or configurations are. When we can clearly differentiate between these configurations, this gives rise to a meaningful measure of distance between them. This process effectively translates differences in information into a geometric framework, where a defined metric emerges from these measurable distinctions. In other words, the inherent uncertainty or randomness described by entropy creates conditions that force states to be differentiable, and this differentiability forms the basis for a geometric structure grounded entirely on information itself. We now delve into the dual foundations of information geometry, highlighting the precise unification between two fundamental metrics: the Fisher-Rao metric, which underpins the geometry of probability distributions, and the Fubini-Study metric, which governs the geometry of quantum states, together form the core structure that defines this field. It is important to note that entropy plays an active role here. Rather than merely describing geometry, entropy actually generates it. This perspective shifts our understanding of the relationship between information measures and geometric structures, emphasizing that the induced geometry is not arbitrary but emerges naturally from these foundational metrics working in tandem. As we move forward, let's focus on how Obidi simplifies complex entropic geometries through a process called coarse graining. This involves three main steps. First, a projection onto macroscopic directions, which reduces the complexity by focusing on larger scale features. Next, averaging over microscopic details helps to balance out smaller fluctuations that can obscure the overall structure. Finally, smoothing removes residual irregularities, allowing the model to stabilize into a clear and manageable form. By applying this method, Obidi effectively reduces an infinite-dimensional, highly complex system into something that can be represented in just 4 dimensions, making it much easier to analyze and work with from a technical standpoint. At this stage, we focus on the key concept that exactly 4 directions remain after considering stability, smoothness, and causality, all supporting a Lorentzian metric. This means the metric induced on these directions corresponds directly to the physical spacetime metric described in Einstein's general relativity. Importantly, spacetime itself is not an initial assumption but emerges from this dynamic selection process, emphasizing that the structure we observe results from underlying physical conditions rather than being predefined. Moving forward, we shift from viewing structures such as Fisher-Rao metrics and alpha connections merely as abstract models to understanding them as intrinsic geometries that define nature itself. Unlike traditional information geometry, which treats these constructs as theoretical tools or approximations, this approach asserts that these geometric structures represent physical reality directly. This perspective frames the emergent spacetime geometry not just as a consequence of models but as a fundamental aspect of the natural world, emphasizing a deeper connection between mathematical formalisms and the actual fabric of reality. Let's now contrast the epistemic and ontological perspectives in relation to key concepts in our current understanding and the proposed theory of everything reality. In the epistemic view, probability distributions represent our lack of knowledge or statistical models, whereas in the ontological view, they correspond to real, structural properties inherent in nature. Quantum states, which we currently treat as mathematical descriptions of possibilities, shift to literal physical configurations in the ontological framework. Finally, what we consider the entropic field as a measure of uncertainty becomes recognized as a primitive, fundamental physical field that underpins the entire universe. This shift from interpreting these elements as abstract or epistemic constructs to acknowledging their concrete physical reality marks a significant conceptual transition in how we model and understand the fundamental nature of reality. Building on Einstein's approach of treating geometry as a physical entity rather than just a coordinate system, Obidi advances this concept by focusing on information itself. Instead of merely considering the physical form or structure, this perspective emphasizes making the geometry of information tangible and fundamental. This shift means viewing information's spatial relationships and structures as inherently physical, mirroring the foundational change Einstein introduced to physics but applied at the information level. This deeper approach aims to uncover underlying principles that govern the physical nature of information, providing a more fundamental understanding that could influence how we analyze and interpret data and phenomena in scientific and technological contexts. Building on this framework, we see how the entropic manifold serves as the foundational source from which the entire physical reality cascades. It splits into two primary aspects: information geometry and coarse graining. These two aspects interact and feed into multiple fundamental components of physics, including spacetime, gravity, motion, causal structure, quantum behavior, fields, and particles. The diagram highlights that what we perceive as physics is essentially a large-scale manifestation of underlying entropic geometry. In this way, physical phenomena emerge as macroscopic expressions of deeply encoded informational patterns, bridging abstract geometric structures with concrete physical realities. This unified perspective offers a comprehensive understanding of how fundamental information shapes everything from the fabric of spacetime to the behavior of matter and energy. Moving forward, this slide highlights the essential questions central to Obidi's proposition and confirms them affirmatively. It addresses whether the entropic field produces an information geometry, whether spacetime emerges from this geometry through a process of coarse graining to 4 dimensions, and whether every point within the entropic field holds the information from which all reality unfolds. Each of these inquiries is answered with a clear yes, emphasizing the proposition's profound, radical, and coherent nature, setting it apart from existing theories. This concise summary helps us grasp the core framework underlying Obidi's approach, paving the way for deeper exploration and understanding. To delve deeper into the fundamental structure of reality, you can consult the detailed formalism and mathematical mechanisms presented in the canonical archives available online. These resources provide comprehensive insights and rigorous explanations that could shed light on the origins and underlying principles of the universe. Exploring these materials will offer a clear understanding of the theoretical framework and may help reveal new perspectives on how the universe truly begins.